Morning, Year 6. I'm starting off this morning in the classroom to get our lessons done, and I'm looking forward to seeing you again. As you can see, we are almost back in the normal school. Teacher mode is back on. I'm looking forward to seeing you guys later on this morning. We're going to be continuing with our lessons on angles in numeracy. Previously we started off by measuring angles with a protractor. We're going to carry on practicing that today. But I want us to start moving towards trigonometry, which is angles within triangles. And for me, this was one of the very few subjects that I was automatically good at in maths. All the other subjects, I struggled through them, or I found them very difficult, and I really had to work hard at them. But for some reason, trigonometry, it just clicked with me, and I really enjoyed this topic. So this is where we're going to start today. We're going to start looking at our angles in triangles. Let's get a blue pen out, shall we? And remember today's date. Today is the 1st of June. We don't have to even look at that because you know today we're starting school. The 1st of June. Right, angles in triangles. There is one thing that will get you out of trouble faster than anything else in this topic, and that is knowing this one thing. And then we're going to do a little practical experiment where I'm going to show you exactly how this works. The total number of degrees, the total degrees, I'll just write that, inside an angle, a triangle, always equals, anybody want to guess? Always equals 180 degrees. You remember this? Trigonometry becomes a breeze. Total degrees inside a triangle always equals 180 degrees. Now what does this mean? I'll show you now. It simply means that inside any angle, any triangle, and I'll draw several here as carefully as I can. Angle A, B, C, A, B, C, all of these angles, all of them, these three ABC, these three ABC, these three ABC, will always equal 180 degrees. Always. And when you remember that, trigonometry becomes a breeze. Now all you will be asked for in such a question is to calculate the value of an unknown angle. And the unknown angle will be very similar to what you've been doing before, when we were just calculating complementary or supplementary angles. Now if you remember correctly, this here, I keep trying to point at my screen like you can see it, this number here might ring a bell, 180 degrees. What does that also equal? 180 degrees is the same number of degrees in a straight line. Now I just want to show you something quickly, hang on. Okay, what I've got here is a triangle. I have not measured any angles on this triangle. I have simply cut it out randomly, okay, from this piece of paper. I haven't measured anything, haven't got out a protractor, haven't used any angles. I've just guessed and cut as straight as I can. I'll do it again. No angles, I'm not measuring anything. I'm just cutting out a random triangle, making sure it's straight sides, that's all I need to worry about. And I want to show you something cool about triangles. So there you go, I haven't measured anything, there's nothing on that other side, no guidelines. I'm simply cutting randomly. Okay? And I'd like you guys to try this also. For those of you coming into school, I'll give you some paper to try with. But this is all that I've got. So as you can see, I'm trying to mimic triangle A plus B plus C in these examples here. Now what I'm going to do is I'm simply going to tear each of the corners off. So that's my angle B, gone. I'm going to tear my angle A, okay? And I'm going to tear my angle C, all from the same triangle. This really doesn't matter, that's just the middle of it. And now I want to show you how the inside angles of a triangle always equal 180 degrees. I'm just going to put a bit of sticky stuff on the back of each piece so that I can stick them down. Just putting a bit of sticky stuff on the back of them. There we go. And now I'm just going to make a little dot anywhere on this. I'm using the back of my diary. Can you see that? That little dot there. Okay. And now watch that dot. I am just going to try and stick as closely as I can these pieces of paper with every single one of those points, the corners, obviously those are the angles from the corners of our triangle, touching the same spot. So that's angle B. Here's angle C. I'm going to make sure that all the angles touch at the same point and touch the edges. And here's my angle A, my last angle. It's going to come on this side. And all I want to do is to make sure that my angles all touch at the same point. And there you can see quite clearly angle A plus B plus C. If you look along the top there, it is a perfect straight line, 180 degrees. You can do this with any triangle. If I had to do it again with this one, just randomly, I'm just going to mark the corners again. A, B, C. Remember, this is also a random triangle that I cut out. And I'm just going to take the corners. Don't worry about that middle bit. And if I hold each point together, you can see that it makes a perfectly straight line on the top. This is proof of this rule here, that the inside angle of a triangle will always add up to 180 degrees. Now, how does this help us? How does this help us calculate unknown angles? I'll show you now. If you look at these shapes here, very, very scary looking shapes, I know. But what would you do if I told you that by the end of these lessons, you would be able to calculate and figure out such shapes? Now, this is really to extend you. It's really to give you the extra practice you need to apply the skills that we're talking about today. But this kind of stuff is what you will be meeting in high school next year and the year after, and as you carry on through your maths in high school. But I promise you, it looks so much more complicated than it is. As we go through the lessons, you will find that by the end of them, you should be able to calculate this kind of maths. So for where we are right now, let's just say, for example, you are given a triangle like this, okay? And you are told that this is 60 degrees. You are told that this is 50 degrees, and you are asked to calculate angle X. Now, you need to remember that all you need to do is remember this rule up here. Total degrees inside a triangle always equals 180 degrees, which means that 60 degrees plus 50 degrees plus x equals 180 degrees. And again, if you remember supplementary angles and complementary angles and how we calculated those, here our magic number is always just going to be 180 degrees. We are going to subtract 60 from 50, 60 plus 50, take those two numbers away from 180 degrees. The remaining value is what is the unknown angle. It's that simple. So here we go. You want to calculate x. We know that the inside angles of any triangle will always equal 180 degrees. Okay? And we want to subtract these two fractions. Not fractions, these two angles, 60 degrees and 50 degrees. Those two together, that's 180 degrees minus 110 degrees. What is x going to be equal to? X is going to be equal to 70 degrees. Remember, you are always subtracting from 180 degrees. It will never be less than 180 degrees when you're calculating triangles, the angles in triangles. It will never be more than. No matter what shape the triangle is. If it is a three-sided shape, it's got three angles and three sides, the inside angles will always equal 180 degrees. I don't even know how that works. It's just maths. It's trigonometry. You can try it. Go and cut out as many triangles as you want. Mark the corners, tear them off, stick them together, and I promise you, every single one of those triangles, the top edge will create 180 degrees. You just need to make sure that every point of the triangle is touching and every edge is touching. The top edge will be 180 degrees. I hope this will make sense to you. We will go over it again in more detail and I can explain it to you more in class.